Good morning. This is J.V.R. Reddy, lecturer in Computer Science, Government Degree College, Sattapalli. Today's topic is data models in dbms. Data models is a logical structure of database. Data models is a logical structure of dbms. It describes the design of database to reflect entities, attributes, and relationships along data constraints and so on. Data models is a logical structure of database. It describes the design of database to it is reflected to attributes, entities, and relationships among data constraint. These data models are the types of data models are ER model and object-oriented model. There are several types of data models in dbms. Here we will just object-based logical models. We will see here there are ER models and object-oriented model. First, ER model. What is ER means? Entity relationship model. Describe the structure of database with the help of a diagram. The structure of database with the help of diagram, which is known as entity relationship diagrams. An ER model is a design or blueprint of a database. It is a design or blueprint of a database that can later be implemented as a database. The main components of ER models are entity set and relationship sets. And first of all, ER model or entity relationship model describe the structure of database. It describes the whole structure of the database. If you want to design a database, we will draw the ER diagram first. Based on the ER diagram, the database structure can be implemented. Here, an ER model design or blueprint of a database can be implemented at database. The main components of ER model is entities and relationship, or entity sets and relationships. Here, what is an entity relationship diagram? An ER diagram shows the relationship among entity sets. An entity set is a group of similar entities, and these entities can have attributes. In terms of DBMS, an entity is a table or attribute of a table in database. So, by showing the relationship among tables and their attributes, ER diagram shows the complete logical structure of database. Let's have a look simple ER diagram to understand the concept. Here, ER diagram shows the entity sets and group of similar entities. Entity set is nothing but a group of similar entities. First of all, what is an entity? Entity is a person, place, object or event is gone as an entity. What is an attribute? Here we see the entities have their attributes. What is an attribute? Attribute is a set of attribute is a characteristics of entities. In a table, or we have entities and attributes. In a table, we have entities and attributes. A simple ER diagram. Let's see. Student. Here, student, college are the two tables. Student have an entity. College is also an entity. Student have a attributes, student ID, student name, student address. Same college entity is also a two attributes. First one is college ID and college name. The two tables have a relationship between study in. This is the relationship. Here, this is the simple ER diagram. Same whatever we discussed about entities to entities, student and college, and then attributes. This is the ER diagram. We go through the matter. In the following number, we have two entities, student and college, and their relationship. The relationship between student and college many to one, as a college can have many students. However, a student can not study in multiple colleges. At the same time, student entity has attributes such as student ID, student name, student address, and college entity has attribute such as here we have a relationship This is many to one relationship. Here, student or students are studying in one college. So, many students can studying in one college. That is many to one relationship. Here, these are the relationship diagrams. So, relationship here diagram. Here, student, college are the entities. Each entity has a attributes. Student have three attributes: student ID, student name and address. College have two attributes: college ID and college name. The two entities or two tables have a relationship. Students are studying in college. This is a simple ER diagram. Here are the geometric shape of their measuring an ER diagram. We will discuss these terms in detail in the ER diagram section. Here, rectangle entity set. Rectangle is the entity set. Ellipse is the attribute. Here, rectangle student and college is the rectangle, that is entity set. Ellipse student ID, student name, student address, college ID, college name are the attributes. Here, study in is diamond, that is relationship set. Lines, the link attributes and entity set of relationship sets. Double ellipse, multivariate attribute. If you have no double ellipse here in this diagram, if double ellipse, that is the meaning of the double ellipse is multivariate attribute. And the dash ellipse, derived attribute. Double rectangle, weak entity set. Double lines, total participation of the entity is a relationship set. Components of an ER diagram. Here, ER model, we have entity, attribute and relationship. In entity, we have a weak entity. Attributes, in attributes you have a keys, composite attribute, multivariate attribute and derived attribute. Relationships, one to many, one to one, many to one, many to many. Components of ER diagram. Entities, attributes and relationships. Entities and the first ER diagram components are entities, attributes and relationships. Entities, attributes and relationships. Here, entity. Here, an entity is an object, event or a concept or a person of a data. An entity is present as rectangle in a ER diagram. For example, in the following ER diagram, we have the two entities, student and college, and these two entities have many to one relationship as many students studying in single college. We will focus on the entities. Here, student, college, study, many to one relationship. Many can displace here m and 1 displaces as 1. Here the same ER diagram here, student and college. And then an entity that cannot be uniquely identified by its own attributes and aligns in a relationship with other entity is called weak entity. If an entity cannot be identified by own attribute and the relationship in other entity is called as weak entity. The weak entity is represented by double rectangle. For example, a bank account can be uniquely identified without knowing the bank to which the account belongs. So, bank account is a weak entity. Here, bank account can be uniquely identified without knowing the bank to which the account belongs. So, bank account is a weak entity. Here, bank and bank account. Here, double lines, double rectangle is the weak entity here. Next one is the attribute. An attribute describes the properties of an entity or characteristics of an entity. An attribute represented as vowel in the ER diagram. There are 4 types of attributes: key attributes, composite attribute, multivariate attribute, derived attribute. First one is the key attribute. A key attribute can be uniquely identified an entity from entity set. For example, student roll number can be uniquely identified a student from a set of students. Key attribute is represented by oval, same as the attribute. However, the text or key attribute is underlined. Here, key attribute is an uniquely identified number, because not only number, uniquely identified. An attribute is an uniquely identified, that is called as an key attribute. For suppose we have a student enrollment number or employee ID, in a employee table employee ID, in a student table student or ticket number or student ID, is the uniquely identified from a set of students or set of employees. The key attribute is represented by vowel, same as other attribute. However, text or key attribute is underlined. Here, key attribute is underlined. Here we have a student. Student have a roll number, name, age and address. Here, key attribute is roll number. So, underlined the roll number here. Composite attribute. An attribute is combination of attributes known as composite attribute. For example, student entity, the student address is a composite attribute, an attribute, a composite of other attributes such as pin code and street and village and town, mandal, district, like that. Here, composite attribute is a combination of other attributes known as composite attribute. Here, composite attribute have more than one attributes. For example, a student have an address. In this address, you have a composite attributes. Student address, in this address, door number, street, state, district, these are all the composite attributes of the address. Multivariate attributes, an attribute that can be hold multiple values known as multivariate attribute. It is represented with double ovals in an ER graph. For example, a person can have more than one phone number. Phone number attribute is multivalued. Here, in this example, multivalued attribute known as multivalued attributes. For suppose it displays the double ovals. In this ER diagram, a person have more than one phone number. That displays the multivariate attribute. Here phone numbers are the multivalued. Here student attribute, so student entity, student phone number is the multivariate attribute. Next one is the derived attribute. A derived attribute is a one, the value is dynamic and derived from other attribute. It is represented by dashed oval. In ER diagram, for example, person age is the derived attribute as it changes every time or over time, and it can be derived from other attribute, date of birth. Here, in this ER diagram, we have a example for multivariate attribute and derived attribute. This is a multivariate attribute. Student entity have student phone number. We have a student have a multi phone numbers. So the student phone number is the multi-valued. Here age is a dashed vowel, where the age is calculated from the date of birth, taken from the date of birth. A age is calculated. The age is automatically changed every time or over time. So it is derived from another attribute is called as age is the derived attribute here. Here we see the attribute, key attribute, composite attribute, multivariate attribute, derived attribute. Here we have a student ID is the key attribute. It is a age is the derived attribute. Student phone number is the multivariate attribute. In this ER diagram, we missed only composite attribute. This is the composite attribute. Here, in an attributes, we have three attributes, four attributes. First one is the key attribute. Second one is the here this is the key attribute. An attribute are described from the properties of entities. An attribute is represented over symbol. There are four types of attributes here. We already seen. First one is the key attribute. Second one is the composite attribute. The next one is the multivariate attribute. Last one is the derived attribute. Key attribute is the attribute a student, for example, the uniquely identified attribute in a entity set is known as key attribute. For example, uniquely identified means that is almost a primary key. Uniquely identified attribute, the student roll number or hall ticket number in a table is uniquely identified. That is key attribute. In this example, in the student table, we have a roll number, name, age and address. Roll number is the key attribute. The key attribute is underlined. Next one is the composite attribute. The combination of other attributes is known as composite attributes. An attribute that is combination of other attributes known as composite attribute. For example, a student entity, the address of the composite attribute as composite values, other attributes such as PIN number of state, country, these are all the composite attributes. The next one is the multivariate attribute. The multivariate is known as the multiple addresses or multiple attributes. If a student have a number of subjects, that is multi-valid. A student have a phone number, that is multi-valid. Here student phone number as the multi-valid in this example. Derived attribute, a value derived from other attribute is known as the derived attribute. Here age is derived from the date of birth, that is called as the derived attribute here. The next one is the relationship. Here we have four types of relationships. It represents the diamond symbol. The relationships among the entities. The first relationship is one-to-one relationship. A person has a passport. A person has a passport. Person here is an entity. When a single instance of an entity associated with a single instance of another entity, then it is called as the one-to-one relationship. A single instances of an entity associated with single instances of other entity. You take the two entities, a single instances of one entity and the same single instances of other entity. That means instance means to store data in the database in a particular time. That is called single instance. At the same time of an entity, at the same single instance of another entity is known as attribute. Is known as one-to-one relationship. Here we see the one-to-one relationship. One person has one passport. Here entity is a person, entity is a passport, has diamond symbol is a relationship, that is one-to-one relationship. It represents one has one. Here one-to-many relationship. When a single instance of an entity associated with more than one instances of other entities, it is called one-to-many relationship. For example, a customer can place many orders, but a order cannot be placed to many customers. Here, a single instance of an entity with more than one instances of another entity, then it is called as one-to-many relationship. A customer orders many, customer places many orders, but a order cannot be placed to many customers. A customer places order. Here 1 to m. The relationship is 1 to many. Many means m. 1 to m. Here many to one relationship. When more than one instances of an entity is associated with a single instances of another entity, it is called many to one relationship. For example, many students can study in single college, but student cannot study in many colleges at the same time. Here more than one instances of many an entity is associated with the single instances of another entity, is called many to one relation, that is m to 1. Many to many relationship. When more than one instances of an entity is associated with the more than one instances of another entity, then it is called many to many relation. For example, a student can be assigned to many projects and project can be assigned to many students. Here we have a relationship. The relationship represents the diamond shape. It is in a ER diagram. The relationship among the entities. First one is one-to-one relationship. In one-to-one relationship, A single instance of an entity is associated with a single instance of another entity, that is one-to-one relation. A person has a passport. A person, single instance. A passport, single instance, one-to-one relation. One-to-many relation, a single instance of one entity, an entity associated with a more than one instances of other entities. A customer places the many orders here. A customer places many orders. Customer is an entity, orders is an entity, placed one to many. Many to many relationship, when more than one instances of an entity is associated with single instances of an entity. Here, many students studies in the same college, one college. That is many to one. The many to many relationship, number of students assigned in the many projects, and the projects can be assigned in the many students. This is the many to many relationship. Total participation of an entity set. Total participation of each entity set must have at least one relationship in a relationship set. For example, in the below diagram, each college must have at least one associated student. Here, student ID, student name, student address. Here, college ID, college name. ER diagram shows with total participation of a college entity set in a single relationship. This indicates that each college must have at least one associated student. Each associated student here. This is the participation of an entity set. In this session, we see in the relationship want to go to the first one. Here you see in the data models here, types of data models, ER model, object oriented model. Here ER model represents the entity relationship diagrams. Here a simple ER diagram here we seen already. Student and college have entities. Student ID, student name, student address are the attributes, and college ID, college name is the attributes in the college entity. Study in is the diamond symbol, that is the relationship. Here we have a rectangle entity set. Rectangle represents the entity set, ellipse represents the attribute, diamonds represents the relationship set, lines the attributes entity set of relationship set, double ellipse multivariate attribute, dashed ellipse derived attribute, double rectangle weak entity set, double lines total participation of an entity in a relationship set. Double lines represents the total participation of an entity in a relationship set. Components of ER diagram is ER model. Today we seen total ER model here. We seen entities and weak entity, attribute, relationship, key, composite, multivariate, derived attributes, relationship one to one, one to many, many to many, one to many, many to one. Okay, components of ER diagram is entity, attributes and relationship. Here these three entities, attributes and relationship. Here entities first. Entity is a object or components or event or a person or place, anything of a data represents a rectangle in a ER diagram. Here student studied in college. An entity can be uniquely identified by the attribute. And a relationship with the other entities is called weak entity. A bank account is a weak entity because without knowing the bank which the account is belongs to, that is a weak entity. We have an attributes, key attribute, composite attribute, multivariate attribute and derived attribute. And relationships is in one to one, one to many, many to one, many to many relationships. And the last one we see the double lines here. This indicates the each college must have at least one associated student. This is the study in college, that is double lines. Thank you.